Hello my precious friends, I really hope that you are doing great. Welcome to today's class. It's our 7th lesson on a given Form 2 mathematics topic called linear motion. So we are looking at our example number 10, which is a past Kcse question done in 209, paper 1 question number 22. So it reads that the diagram below shows a speed time graph, meaning that on the vertical axis we are having the speed, then on the horizontal axis we are having a time for a train traveling between two stations. So the train starts from rest. Remember, from rest means that the initial speed is 0 meters per second and accelerates uniformly for 150 seconds. To accelerate simply means to move with increasing speed. So you can see from 0, it is actually accelerating up to this particular point. Then you are told that it is accelerating for 150 seconds. Therefore, the distance from or the time from rest to the point where it stops accelerating, we are told that the time is 150 seconds. It then travels at a constant speed for 300 seconds. So this is the period where it is traveling at a constant speed. You can see the speed is actually remaining constant between this particular period. Then it's traveling at a constant speed for 300 seconds. Therefore, I need to get the time at this particular point, that is when it stops moving at a constant speed. So I'll simply take the 150, then I add the 300 seconds, which is going to give me 450 seconds. Therefore, at this point, we are having the 450 seconds. Then you are told that, and finally decelerates. The other term for decelerating is retardation. So to decelerate simply means to move with a reducing velocity with time. So it finally decelerates uniformly for 200 seconds. So this is the period whereby it is decelerating, because it's moving from the maximum speed to actually 0. So we are told that it decelerates uniformly for 200 seconds. Therefore, if I take 450, I add the 200 seconds, it is going to take me to 650 seconds mark. So this is the 650 seconds mark. So that is the simple description of the given motion. Then we are told that given that the distance between the two stations is 10,450 meters, calculate part A, the maximum speed in kilometers per hour the train attained. So there is one fact that you need to always remember, that distance, whenever you find the area under a speed time graph, it should always give you the distance. So we need to know that the area under a speed time graph, will always give you the distance. The area under a speed time graph should always give you the distance. So this one should always give you the distance that was covered. Then the area under this particular speed time graph, this area is in form of a trapezium. Therefore, it means the area of the trapezium, which is given by a half into a plus b multiplied by height, it should give us the total distance, and we are told that the total distance is 10,450. So this one should give us 10,450 meters. So this will be equal to a half, then into the value of A and B. Remember, A and B are usually the parallel side. So this is the first parallel side. Then we have the other parallel side. So the time between this parallel side will be the time which is 450. Then we are going to subtract the time at this particular point. So this is the length of our first parallel, the smaller parallel side. So this is our A. Then the smaller side is, the larger side is our B. So the A will be 450 minus 150. So if you take 450, then you subtract 150, you are going to get 300 seconds as the period of our smaller parallel side. So this is 300 seconds, then plus our side B will be the distance from this particular point up to this other point, which is actually 650 seconds. Then we multiply with the height is usually the perpendicular distance between the parallel side, which is this distance here, which is actually equal to our maximum speed. So I'm going to let the maximum speed to be x meters per second, because that is what we are asked to find. So the height will be the maximum speed, that is from 0 up to x. This is our height between the two parallel sides. So our height is actually the maximum speed, which is x, should be able to give us 10,450 meters. So this will be equal to, so we are going to have a half, then multiplied by, if I take 300, then I add 650, I'm going to get 950. So this will be 950. Then of course we had an x here, multiplied by x, should be able to give us 10,450. So if I take 950 divided by 2, I'm going to get 475. So this will give me, so 2 will go here 1, then of course 2 into 950, I'm going to get 475. Then of course we still have our x, so this will be 475x. 475x is equals to 10,450. Then I divide through by 475. I also divide through by 475. So this one simply means that our value of x will be given by, so our x is going to give us, of course, 475 and 475 will cancel out, so that our value of x will be equal to, so our x is 10,450 divided by 475, which is going to give us 22. So our x will be 22. Then remember, x was the maximum speed in meters per second, therefore our x is 22 meters per second. But part A wanted us to find the maximum speed in kilometers per hour. So this will be equal to 22 meters per second is the same as saying 22 meters then divided by 1 second. Therefore, if I want to convert into kilometers per hour, I'll convert my distance into kilometers. We know that 1,000 meters is equals to 1 kilometer. What about 22 meters? So this will be over 1,000 meters multiplied by 1 kilometer. Then if I change the seconds into hours, this will be over 3,600 seconds, then multiplied by 1 hour. So this is going to give me 22. So I'm going to have 22 divided by 1,000. You're going to get 0.022 kilometers. Then divided by, if I take 1 divided by 3,600, I'm going to get, yeah, it will just be 1 over, so this will be 1 over 3,600 hours. Then if I divide the 2, if you take 0.022, then you divide with, if you divide with 1, if I divide with 1 over 3,600, I'm going to get 79. So this will give me 79.2 kilometers per hour. 79.2 kilometers per hour. So that is the maximum speed that was attained in kilometers per hour. That will be our maximum speed. Then we can move to part B of the question. So part B of the question wants us to find the acceleration. They want us to find the acceleration. So remember, the body is accelerating between rest up to the maximum speed. So this is the only period where our body is accelerating, because at this particular point the body remains constant, then at the last part the body is decelerating. Therefore, for part B of our question, of course, acceleration is equals to change in velocity, which is final velocity minus initial velocity, then divided by the time taken. So this will be equal to, so from this particular point up to when the body attains the maximum speed, actually acceleration will be the final velocity. For this particular case will be our x, which was the maximum speed, but we have just found that our value of x is 22 meters per second. Therefore, our final velocity will be at this point. Initial velocity will just be u, because the body started at rest. then the time taken will be the time between 0 up to 150 seconds. So our final velocity, of course, is 22 meters per second, then minus the initial velocity when the body starts accelerating is our 0 meters per second because the body started from rest, then divided by the time taken from rest up to when the body stops accelerating is 150 seconds minus 0, which will just give us 150 seconds. Therefore, this will be 22 divided by 150, which is going to give us 22 divided by 150. I'm going to get 11 over 75. So this will give me 11 over 75 meters per second squared. So this is the acceleration of this particular body. Then we can move to part C of the question. Let's move to part C of the question. So in part C, they want us to find, maybe I can indicate the values that I've gotten in case I'll need some reference. Our value of x, we got it as 22 meters per second, which was 79.2 kilometers per hour. Then part C of the question, in part C, they want us to find the distance the train traveled during the last 100 seconds. The distance the train traveled during the last 100 seconds. So the last 100 seconds in this diagram represents, if you take 650 minus 100, you are going to get 550. So up to the 550 mark, this is what we are calling our last 100 seconds. So this particular period here, so this diagram, actually the shaded area represents the distance during the last 100 seconds. Then remember we said that the distance under a speed time graph or the area under a speed time graph should give you the distance. Therefore, it means that the distance traveled during the last 100 seconds will simply be equal to the area under this particular speed time graph. So the area under will be equal to the area under our speed time graph during the last 100 seconds. So if you look at this particular area, because the motion is uniform, it means that this particular area will be given by a half base times height, because you can clearly see that this is a right angle triangle. Then this distance will be equivalent to, I want to show us the distance here. So remember, this one will be up to a half because the motion is actually uniform. So this one should correspond to a half of 22 meters per second, which will be 11 meters per second. Therefore, the distance will be equal to the area under speed time graph during the last 100 seconds, which will be equal to, because this area is in the shape of a triangle, a right angle triangle, it will be equal to a half base multiplied by height, which will be equal to a half of the base will be the distance from 650 up to 550. So the time difference will actually be 100 seconds. So this will be a half of the base is 100 seconds, then multiplied by the height. The height will be equivalent to a half of 22. Yeah, because this is a half of this particular triangle from 650 up to 450. From 450 to 650, we had a time of 200 seconds. So a half of 200 is 100 seconds. So this 100 will also correspond to a half of the maximum speed, which is 22 over 2. You're going to get 11 meters per second. Therefore, our height, this particular distance, will just be 11 meters per second. So multiplied by 11 meters per second. So this is going to give us 2 here, 2 into 100, that is 50. So we are going to have 50 multiplied by 11, which is going to give us 50 by 11. We are going to get 550 meters. So that distance will be 550 meters. So this is the distance that the train traveled during the last 100 seconds. Then we look at part D, which is telling us to find the time the train traveled. The time the train takes to travel the first half of the journey, the time that the train takes to travel the first half of the journey. So in order for us to get the first half of the journey, I'm going to determine where that half is actually going to lie. So let me redraw another diagram here so that we can exactly see what is happening in this particular question. This should give us, let me draw a line to separate my working here. So that is my line. So the line should be this way. That is my vertical line. So remember, we have this particular diagram here. So let me just sketch it. So we have this. We have this one here, the vertical line here. Then we have this horizontal line here. Then we have our motion from this particular point. Then from this point it's becoming constant. Then it moves to the remaining distance. So of course this is we are looking at our part D of the question. So this is our diagram. So they want us to find the time the train takes to travel the first half of the journey. So the first half of the journey should correspond to the half of the total distance. So if we find half of the total distance, so a half of the total distance was 10,450. So if we find a half of 10,450, we are going to get the following. So this will be equivalent to 10,450 divided by 2. We are going to get 52. So half of the distance is 5,225 meters. So this is what is representing half of the journey. So that is half of the distance. So I need to determine where this distance lies. Therefore I can subdivide this one into 2. We are asked the first half of the journey. So I need to find this particular distance of the first triangle. So that distance will be a half multiplied by, the base was 150. So 150 multiplied by, the height was actually 22. So that distance will be equal to, if I take a half, so a half multiplied by 150, then multiplied by 22, I'm going to get 16. So this is 1650. So the distance of this first part is 1650. But we want half of that. Half of that is 5,525. So that means that distance is not in the first triangle. So probably it could be in the second triangle. Let's try to find the area of this figure here. This can be our figure A, this is B, then this is our figure C. So of course figure B is a rectangle whose area should be length multiplied by width. So that should be, our length is 450 minus 150. So the length is 300. So that is 300. Then multiplied by our height, that is the width, will actually be the 22. Multiplied by 22. So this should give us 22. So if I take 300 times 22, I'm going to get 600. So if I add these two distances, if I take 1650 plus whatever I've gotten, so if I add to 1650, I'm getting that distance will be 8250. But remember, the distance that we want is 5225, and this is already 8,000. So this one is suggesting to us that the distance that we are looking for, it lies in this particular figure B. So that distance actually lies through this particular figure, because the whole of this area from the starting point, if you add the area of the first triangle plus the second rectangle, it is exceeding half of our distance. So I'm going to let the time from the starting point to half of the journey to be x. So I'm going to let this particular time to be x. I'm going to assume that half of the journey is at this point, so that I let this time to be x meters. That is x seconds. So this is the area that we want to look for. This is the area that is representing half of the journey. So we know that the area under a speed time graph should always give you the distance. So half of the distance that you are looking for is 52, 5. This one should take us to half of the distance, which should be equal to, you can see this particular shape. This shape is actually a trapezium. So this should be equal to the area of the trapezium, which is a half into A plus B, then multiplied by height. So that means 52, 25 should be able to give us a half into A. A will be the this particular parallel distance, then this will be our B. So our A will be, if this is X, it means this distance will be, remember here we had, this was 150. So at this point, this was 150. So it means our distance B will be X minus 150. So this will be X minus 150. So that is our distance B. Then if I add the distance A, so the A will be this lower distance, the distance from the starting point up to this point, which is X minus 0. So X minus 0. Then multiplied by the height will be the perpendicular distance between the two parallel sides, this distance here, which was actually 22. It will simply be equal to this distance, which was 22 meters per second. So I'm going to multiply with the height, which is 22. So I multiply with 22. So if we get the value of X, we would have gotten the time that the train takes to travel the first half of the journey. So this will be equal to, so I can divide through. So of course 2 here, 2 into 22, that is 11 times. So I'm going to remain with 52 to 5 being equal to, if I add the values in the bracket, X plus X, I'm going to get 2X. Then of course negative 150 minus 0, I'll simply get negative 150, then multiplied by 11. Then I want to open this bracket, so I'm going to have 5, 2 to 5 being equal to 11 times 2x, I'm going to get positive 22x, then minus 150 multiplied by 11, I'm going to get 1650. Therefore, if I take this to the other side, I'm going to have 522 5 plus 1650 being equal to 22x. So if I take 1650, then I add 522 5, I'm going to get 6875. So 6875 should be able to give me 22x. So that is 522 5. If you add to 1650, you are going to get 6875 is equals to 22x. So this one will simply mean that our value of x will be given by, so that means our x will be equal to, so x will be equal to 6875 then divided by 22, which is going to give us, divide by 22, so I'll get my x being equal to 312, 312.5. But x, remember, it was on the time axis, therefore these are seconds. So this is the time that it will take the train, that is the time the train takes to travel the first half of the journey will be 312.5 seconds. Thank you very much for accompanying me until the end of this particular lesson. I do not take it for granted. In case you are new to the channel, kindly hit the subscription button and also turn on the notification bell so that whenever I upload a new video, you'll get notified. So until next time, this is Kind Tuition Academy. Thank you very much.